Hello, beautiful people and future me. Welcome to another programming workout of mine. Uh, so let's start. We start with the typing. Oh, that's too big window. That's okay. And we will do the typing practice. And after that, I think I will continue in the execute program. Yeah, let's do that. So I will start the clock. And let's improve our typing. Yesterday I had some really nice numbers regarding the typos, so let's see if we can keep it. All right. So what is the result? The result is 3%, which is better than I thought I will get, given the errors in the beginning. Also, I did not like this exercise today for some reason. I did not want to do it, but I tried to just have it in the background, just give it so much importance. So I said we will be doing the execute program. So let's head up to the page. Let's continue in there. So we'll go to the next lesson and what we will do. Okay, so let's kinda wheel of names. Okay, and we have JavaScript, SQL, and TypeScript. So it will be JavaScript, script, SQL, and TypeScript. Let's see what it will be. And it looks like JavaScript. Oh, maybe TypeScript. Maybe. Ah! Okay, TypeScript it is. Let's do that. And I have 3 lessons ready for me now. That is wonderful. We have logical operator narrowing. Okay, I don't know what that is. We have any, which is the type, I believe. I think I already started it, kinda, a little bit, but I did not finish it. And we have index signatures, which I have no idea what it could be. So that is awesome. I want to learn about that. Okay, so index signatures. We've seen object types that include specific keys. Show me. Hmm. Object types that include specific keys. Uh, what do you mean? Like specific keys. This is the key, like the name, like type user have this is a key and this is a value, I guess. So Amir name will be Amir. What about objects where we don't know the keys in advance? For example, we might want a login counts object type that maps users' names to how many times they've logged in. We can't explicitly write out the keys for that object type because we don't know all of the users' names at compile time. Okay, so this entire chapter is called index signatures. And they are now saying that we don't know the keys in advance. So the key is Emir. Maybe the index is the name in here. Well, it would make sense for like an array, right? We could say like if this would be Emir would be an array, we could do or array dot one to well use the square brackets, but we can use Emir square bracket name. So maybe that's what they meant. That's what they mean. Object type that maps users. We might want a login counts object type. Okay, so that would be another type that maps users' names to how many times we've logged in. Okay, so the key will be okay. Yeah, and we can explicitly write out the keys, which means this, because that would be the login count, and it would be like a mayor, and then colon, and the number of the things, I think. Okay, so fortunately, TypeScript has a way to express this type The syntax is based on ES 2050's computed keys feature. So we'll review that first. Okay, show me. When creating an object, we can write the keys as unquoted words like Amir in this example. Login counts, Amir. Yeah, that one I can understand. That's the normal way. We can also create object with computed keys. To do that, we wrap the key in square brackets like so. So this is the object, and instead of the key, we have a something in a square brackets and then the value. Okay, and there's a constant of name. Okay, and login counts. We have this. We take the constant, the variable in here, and then we output it. Okay, that I understand. The square brackets can contain any expression, not just simple variables. For example, we can use string concatenation to build the key dynamically. Oh, so expression, or maybe add some numbers and so on. So there's a BETTI, so that will be Betty. Okay, and the login count is 7. Okay, I can understand that, that's good. Typescript has a similar syntax for defining. Okay, so this was still the ES 2015. Typescript has similar syntax for defining object types with arbitrary keys. Arbitrary, that means like chosen by will or something. Like any. Yes. Random is arbitrary. Okay. Okay. Based on a random choice or personal whim rather than any reason system. Okay. Yeah, I have translation in here. Well, okay, next time. Here's a logic counts type. Here's a logic counts type for objects that map strings to a numbers. Show me, master. Okay, so there's a type with name logic counts, and it is an object which the key is some string called username, and the value is some number. Okay, then we have a logging count, which is an object which contains two things. And let's say the login counts. Okay, so the constant login count with a type of login count. Oh, someone called me. I did not know this. Well, never mind. I'll call back. Map strings, the numbers. Okay, so I'm a little bit confused about this because here we have a constant. Here goes the name of the object, and the type is this guy, right? So I would I would think that it should contain one of those, like one username and one number. But that is not what I see. I see there's a 1 and there's a second one. Well, by the logic, I also I see it, the output will be 7, but it's really surprising to me that you can have a 2 or more maybe. Okay, so I will write 7 in there, and that is correct. Object with arbitrary keys. There, then I have a question, and that would be, can I define and type which would have only one key, define it like this, and one value? And if so, if I can do that, how? Or can I define like, let's have 5 fields of that? Because normally I would think you would write this, comma, and you put that again and do it 5 times. But it does not look like it works like this. Okay, so that is a question for tomorrow. Let's put pin on that. Any object that violates the type will cause a type error. You can indicate type errors with type error, okay? So this is a string and we want the number, so this is the type error. Objects with these types are still regular objects. What does it mean, regular, like normal? Okay. The type just describes the type of the keys and the values. Okay. So now we have the first example we had with this. Is this the name, the type index signature already? Maybe. I think. Oh, this probably means that it's the index when it's in the square brackets. So this would be the index. And the whole signature would be the name for that field. It is a string and a number. What if I want to have like username, that would be string, and let's say user surname, that would be string, or I don't know, like let's not do, yeah, user surname, and then the value, or like there would be like another string and a number, but I would want to express something else. Maybe only this would hold, like would change for everyone, but then the other fields have to be non-index, maybe. So you would have like Amir, and then you have a number, then comma, you would have without the square brackets, like country, for example. That would be string. That's my thinking. Maybe. In our type above, we named the key username. Sure. TypeScript doesn't care whether we name it username or key or s or anything else. That makes sense. But if it's a good idea to use a name that indicates intent, I agree. We intend for this object's keys to be users' names, and the username communicates that to the next person who reads our type. Yeah, that's very important. You should read it as a book. This kind of type is called index signature. Okay, so I was right. Okay, so the entire type is index signature. So it is index signature type. Okay. Index because it's defining the indexes, that is the keys of an object. Okay, so maybe one key only. Okay, still a little bit confused about the values. You have a key, then you have a and just thinking, can you have multiple values? That's I think what and can you give a name to a value? Hmm? I don't know. This kind of type is called index signature. Index is because defining the indexes. Signature because it defines the object's overall signature in the same way that type for the function, like input and number and output string, defines a function signature. Mm. Write the index signature for an object that maps a person's name, a string, to a city. String or undefined. Okay, so it will be person name and the city. So type cities will have okay, so we have these brackets, then here comes the index, and here we will have some type for the field in it, and that would be it. I don't think we need semicolon. So the first will be uh, name, and the type will be string, and then the field would be a string or defined. So we say string, and I think we can do this undefined, like so. This should mean or, and let's try that. Run. No, that is not how you do it. So let's compare this. The columns are on the same place. That's good. But then the output thing, this one is not colored for some reason. So maybe two pipes. And that is also not right. I'm just making fun now. I think it was this. Why it does not work? So string, yes. Ah, I see. Okay, so I did an error, and that is I'm defining an object. So for the object, we use the curly braces. This is one, maybe somewhere, yeah. And here's the second one. And now we got the color in here and the color in here. It looks much nicer. So when I run it, successful. Okay, so we'll continue. Index signatures, key types must be strings or numbers. Yep. Keys I thought that the key is a string and the value is strings or numbers. Da, 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 da. Keys and the values. Okay. I think they made mistake. Typescript. Okay. Value pair. Yeah, here they say the same thing. Here is a key, and so this is a key, and this would be the value. So they might have a typo in here. Keys must be string or numbers. Can I report this? Give feedback. Copy. Human value must be strings or numbers. Am I wrong? Send. Next business may, sure. Must be strings or numbers. When they are numbers, they define an array type. No, they were. My bad, my bad. I will probably tell me that I've given bad feedback. Well, it happened. I just realized. So the keys, this could be either string or numbers, and that's it. Must be strings or numbers. They are numbers. They define an array type. Here's an array type written normally. Yeah, so strings, that would be A, Y. Here's the same array with type written using an index signature. We wouldn't normally do this, but it nicely demonstrates that JavaScript arrays are just objects with the number keys. Number, string, and then Oh, really? You can do this? Okay, so this will be A. We can't create an index signature that allows string and number keys in the same object. That's a type error. Okay, show me. Okay, so this is a type error, you say, because we have a string or a number. It's possible to mix an index signature with explicit definitions of certain fields. When we do that, the other field must match the index signature. What other fields? We can think of the index signature as being the overall type for the object. Overall type for the object, okay. Any individual fields must conform to that overall type, otherwise it's type error. So we have a, okay, cool. So we have a username string number, and then we have a Amir num. Okay, now I'm not sure. So here goes to the question I had previously, and that is if you can have specified something else in here. So here we would have like two values, maybe. So the first one is a number, and then we have a Betty and number. So this would be type error, but if we reverse those two, would it be okay? It's oh, okay. So then we get this, I guess, this, and we will have um, Amir 5, and then we will have Betty with 7. Okay, okay, so this works for some reason. What if we don't have Amir in there? So Amir 5, so here's Amir, and it's a string, but oh, it is string. Okay, so this would be okay, I guess. So it will say Amir, and the value will be 5, and then we will have Betty, and the value will be 7. No? Any individual fields must conform to that overall type. Okay, so this is the overall type, and that means string number. But here we have a string and string. So this would be the type error they talked about. Okay. Here we have another example. Type login counts. We have a username. String number, and here is a Amir string. So I think we are missing Amir. That looks to me like required field. That would be the first thing. So I will say type error. That's true. And type error is property Amir of type string is not assignable to string. To string index type. Okay, so even before this, it will burn on this one. So I would like to know if we have this and we will say bet this would be number, and we would have Betty 7, if that would blow up. Finally, a warning about index signatures. Consider the index signature key string. It says every key is a string that maps to a string value. Okay, but that's impossible because there's an infinite number of possible strings that could be keys. What? I don't see the problem. I don't see the problem. Could you explain? Finally, warning about index signature is considered to be signature key, string, okay. What's the problem here? If we use that signature, then access a key that doesn't exist will get undefined, even though there is no undefined in the type. Okay, got it. the type system will think that we've got a string even though it's actually an undefined. Oh, okay, okay, so I don't understand this. What is impossible? Okay, so every key is a string that maps to a string value, and we will not define every single letter combination, every single string. That's what you are saying. Okay, and will get undefined even though it's not undefined. So now we have a string and in it is undefined instead of a string. So that is a problem. Okay, we have an email string, then we have usernames, and this is Amir example, but this should be email. And there's a string. So this looks to me like it should work because we have a string and string. What is the difference? Because here we have a string, a number, right? And or here, a string, number, string, number. And when we print it out, it just goes. And here we have defined the type. The key is an email. Why do we define the name of this? Like the username, if it's just an index? Because we never say cities.name, do we? So here it says email, and email is a string, and we put in. Oh, okay, so this is the name of the field. This is not a string. So this is a problem. And it should be. This is weird. It should be like usernames, and here will be some string, colon, and the value. And this will get as undefined. Okay, so maybe I understand more what you meant. Because this key, you don't have to anywhere like. Maybe I'm not fully understanding. And what I mean by it is this should be string. Can you do email, colon, and the value? I don't think so. So usernames Amir will give us amirexample.com? I'm confused now. It does. And usernames Betty will give us undefined. Yeah. Wow. The index signature keys that every key in the object says that every key in the object maps to a string, but that's not true. So accessing missing keys give us undefined. Okay. And this code is wrong, but unfortunately it's allowed. Okay, so this will give us the undefined. I see. I see. Let's look once again at the definition. Yeah, so here is not a string. They put like just the key without the quotes. I mean, it is a string, but it's not evaluated as a string. You know, it's not in single or double quotes. That's what I want to say. Every single time. Not a single time they do that in here. Okay. And then here they did. Why is here undefined? Because it does not return anything by itself. Why it doesn't show like all of the things? Like, okay, so this is not the, and we are looking at the last line. So this maybe returns undefined, and this would return that thing. Oh, okay. So this is called index signatures. Index signatures, and we finished it. And because we are 31 minutes in, that means we are done. And done, please remember, it's always better than perfect. Bye. Wrong button.